Hi, today we are on the chapter of complex number. Today we will learn how to find the nth root of a number. But before that, you must know what is De Moivre's theorem. Now, if z is equals to r into cos theta plus I sin theta, or it can also be written in the Euler form r ei theta. Now this form is called the polar form. This is called the Euler's form. Now then, z to the power of n will be given by r to the power of n cos n theta plus I sin n theta. Now if we were to write this in Euler's form, yes, then this should be r to the power n ei n theta. Now, what will this be? Now, if z to the power of 1 over n will be equals to r to the power of 1 over n cos theta plus 2k pi divided by n into I sin theta plus 2k pi divided by n. Or in Euler's form, you also can write it in this way. Ei theta plus 2k pi over n. Now, theta must be between, or theta plus 2k pi over n must be between pi and minus pi. Okay, this is the definition of the argument for the complex number. Now, there's a criteria for these two conditions. N has to be greater than or equals to 1. Now you look at this, when n is a number greater than 1, then you apply this. Now when z to the power of a number that is smaller than 1, like z to the power of 1/3, z to the power of 2/3, then you apply this formula here. Now, why there's a 2k pi here? Now, because sine and cos has a period of 2k pi. All right, so if you have to divide, you must plus 2k pi before you divide by n. Now, you will notice that this one, if z is this, then z to the power n will only have one solution if n is greater than 1. Now, if 1 over n is smaller, if this is to a root, all right, where this is smaller than 1, okay, now n is greater than 1, 1 over n will be smaller than 1. Then you find that you have more than one answer. Now I give you an analogy. Now let's say x squared is 4. Then I want the square of x squared. X to the power of 4 will be 16. Alright, square of this, you square both sides. You'll find that there's only one answer to this. But what is the value of x? Alright, from here, alright, what do you imply? From here, you'll find that x will be equals to plus minus 2. you do a square root that is to the power of half on both sides. All right, then you get a plus minus. So you look at it, it's just the same. When this is to the power of half or 1/3 or 3/4 or so on and so forth, you will find that you will have more than one answers. Whereas if this is a whole number, all right, you will have, whereas if this is n greater than 1, you will find that, all right, you will only have one answer. Now, without further ado, let's try to solve the first sum here. Now, you are asked to find the values of z, all the values of z, such that z cubed equals to 1. When they say all right, they are saying that z can be real or complex. So, now, it is given that z cubed equals to 1. Now, we try to express this in polar form or Euler form. Now, what is the modulus of 1? Is still 1. All right, so this can be rewritten as 1 times e. Now, what is the argument of 1? All right, is 0. Now, so you don't forget to plus 2k pi, okay? So, plus 2k pi. Now, so z will be equals to 1 times e to the power of something is still this part, all right? So, it's e to the power of 2k pi. Then z will be equals to ei 2k pi divided by 3. Now, k takes on the value of 0, 1, and 2. Now, just now I forgot to mention. Now, what values of n, all right, or k must take? K will take the value of 0, 1, 2 until n minus 1. Okay, dot, 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 dot until n minus 1. All right, 1 less than n. So this will be 1 less than 3, which will give you 2. So what are values of z? So we substitute 0 into, all this value of k into z. So z will be equals to e to the power of 0 is 1. Then e to the power of 2 pi over 3 followed by e I 4 pi over 3. Now 4 pi over 3 is out of range. All right. So what you do? You minus 2 pi. Every time it's out of range, you always minus 2 pi multiples. You minus multiples of 2 pi or plus multiples of 2 pi until you get it to be within this range. So in this case, you minus 2 pi. So this you will get. Now you minus 2 pi. 2 pi is 6 pi over 3. So this one minus 6 pi over 3 is minus 2 pi over 3. Now let's represent this on the Argand diagram. Now you'll find that they have the modulus of 1. So this one will be represented by this. All right. All of them will share the same modulus. That's why all of them will fall on a circle. Okay, because this part, all right, from 0 to the complex number, this length is the modulus of the complex number. And all these complex number has 1 as a modulus. Okay, so it must fall within on this circle, on the circumference of the circle. And the angle, all right, it makes with the positive x-axis is 2 pi over 3. Okay, so this will be EI 2 pi over 3. Now what is the other one? The other one is minus 2 pi over 3. EI minus 2 pi over 3. Okay, so these three are the complex number that satisfy this equation. We shall move on to part 2, but before that, I need to erase the board to create some space for the working for this to this question. Part 2, z to the power of 4 is 1 plus I root 3. Now let's express this in Euler's form. Now what is the modulus of z to the power of 4? This will be equals to the square root. The square of 1 is 1, square of root 3 is 3, so this is 2. Now what is the argument of z to the power of 4? Now this is in the first quadrant, so that will be tangent inverse root 3 over 1, and that gives you pi over 3. Now so z to the power of 4 can be rewritten as 2 I pi over 3. Now so it can be further expressed in pi over 3 plus 2k pi. So z will be equals to, now you must take the fourth root of this whole thing. So according to De Moivre's theorem, alright, this will be the fourth root of 2 I pi over 3 plus 2k pi whole thing over 4. Now that will be equals to 2 to the power of a quarter EI pi plus 6k pi over 12. Alright, so what does the value of k, what is the value of k? Alright, k takes on 0, 1, 2, and 3. It's always 1 less than this value of n. So our n is 4. So k takes 0, 1, 2, 3. So the value of z will be z. Now you put 0 inside, so z will be 2 to the power of quarter EI pi over 12. You put 1 inside, is 2 to the power of a quarter EI 7 pi over 12. And 2, what will you get? 2, you put 2 inside, you get 2 to the power of a quarter EI 13 pi over 12. And the last one, you got 2 to the power of a quarter EI, you put 3 inside, so 3 times 6, 18, 18 plus 1 is 19. 19 pi over 12. Now, you will notice that this 2 is out of range. Alright, your argument must be between minus pi and pi, and this is more than pi, and this is more than pi as well. So we have to reduce it to be between minus pi and pi. How do we reduce? We plus multiples of 2 pi or minus multiples of 2 pi. In this case, all right, we minus 2 pi, all right, we will be within the range. So z, let me use red again. The first two is the same. So z will be equals to 2 to the power of a quarter ei pi divided by 12, 2 to the power of a quarter ei 7 pi over 12. Now this is 2 to the power of a quarter. Now you minus 2 pi. Minus 2 pi means what? Minus, that means 13 minus 24. Alright, 13 minus 24 divided by 12. Okay, so what will you get? You got minus 11 pi over 12. E minus 11 pi over 12. Now you come to the last one. The last one, you have 2 to the power of a quarter. Now 19 pi over 12 minus 24 pi over 12, what do you get? You got minus 5 pi over 12. 5 pi over 12. This equal shouldn't be there. Now, so let's represent this on an Argand diagram. Okay. Now, pi over 12 is 15 degree. So this circle, this radius, all right, the radius of the circle is 2 to the power of a quarter. All right, so this length here is 2 to the power of a quarter. Okay. Now, this angle here will be pi over 12. The next one is 7 pi over 12. All right, so this is the first one. Now from here to here, it will be 7 pi over 12. Maybe I just put an arrow, 7 pi over 12. Now, the third one is minus 11 pi over 12. So, all right. So what is this angle? This is minus 11 pi over 12. Now this is minus 11 pi over 12. Okay. Now how about the last one here? The last one is minus 5 pi over 12. This is minus 5 pi over 12. All right. These are the four of the possible answers for Z. For that, we have come to the end of this question. Thank you very much, and we hope that you have learned something from this video.